Hey Math 1, what you're seeing right now is kind of an impromptu video that I'm recording. I feel like we're making mistakes on this 2.3 homework, and there's not going to be a lot of turnaround time to fix them if you don't see the mistakes you're making right now. So, what I'm going to do is make a video of the entire 2.13 homework, which is due Friday at 8 p.m. That's tonight. And I'm going to show you all the even solutions. What I want you to do is make sure you do the even solutions correctly if you did them wrong, and then make the adjustments on the odds so that you guys are moving forward with your understanding. Do the extra credit, 2.14, and I think we'll have a good, we'll have a good go at this. So, number 2. On every single one of these, unless the direction states otherwise, we're getting x by itself. So we're doing 2w. I'm going to do x in a different color just to kind of say, hey, that's different. That's the thing we're trying to get by itself. Minus 3y equals 5. So what you should be doing is saying, add or subtract what is not connected to the red x through multiplication. Add or subtract what is not connected to that red x through multiplication. So x is being multiplied by both 2 and w. So you're not going to add or subtract 2w. You are going to get rid of the 3y. Even though 5 doesn't have a y, I'm going to add 3y to the left and move it to the right. So that gives us 2w x equals, now 5 plus 3y is not 8y. 5 plus 3y cannot be simplified. It is what it is. All right, last move. Divide by whatever is multiplied by the red x. So 2 times w times x, dividing by 2w creates the red x by itself. That's what we wanted. So you're going to divide this by 2w and this by 2w. We're basically dividing both the left and the right-hand side by 2w. If it's on the right-hand side, everybody divides it individually. So x equals 5 over 2w plus 3y over 2w. Number 2 is done. Number 4, on the way. Now, I already did this for first hour, but it's not a bad idea to do it again, just in case you guys were in la-la land when I was explaining things. So, if you see a fraction on the left, on the right-hand side, it's a whole number, you can put that over 1 just to visualize a fraction equals a fraction. You can use cross-multiplying to get rid of those fractions. So you're going to take 3w times 8z, and then you're going to take 1 times everybody in the top. So 1, I'm going to put parentheses around it, 7y minus 2x. It's that x we're trying to get by itself. So remember, 3w times 8z can be multiplied because 3w times 8z is equal to 3 times w times 8 times z. If it's a string of multiplication, then you can use the commutative property to rearrange. Switch the w in the 8 and you get 3 times 8 times w times z. That's 24 wz. And then on the right-hand side, anything times 1 is itself, so it's going to be 7y. And it's still going to be minus 2x. Now again, add or subtract the term that's not connected to x using multiplication. 7y is not connected to x with multiplication. So I'm going to take the positive 7y and subtract it from both sides. So they cancel on the right, and you're left with 24wz minus 7y. That equals a negative 2, because it's 0 minus 2, x. All right, and then we're pretty much done. We just got to divide by the thing that's multiplied by the red x. Divide the right by negative 2, and divide the left by negative 2. So I'm going to rewrite this with x on the left-hand side. Remember, that's the symmetric property. You can do that. And then I'm going to simplify 24wz over negative 2 and call it negative 12wz. And then negative 7 divided by negative 2 yields a positive value. So it's just going to be plus 7y over 2. Number 6. Oh, I don't want to do that. Yeah. Number 6. All right, I see a fraction on the right. I'm going to make a fraction on the left. If a fraction equals a fraction, you can use cross multiplication to get rid of that fraction. 1 times r is 1r, or just r. On this other side, I got to be creative about this. I'm going to take the v and multiply it by the quantity x minus 2. I gotta put that x minus 2 in parentheses because the v is multiplied by both parts. And I should highlight the fact that x is red. It's the variable trying to get by itself. So I got to break it out of its grouping symbols. So I'm going to multiply v times x to get v x, and then take v times negative 2, which is negative 2v, and that all equals r. Now, I think some of you guys are making the mistake where when you don't see a lot of numbers, you just tend to think, I'm just going to divide by the black ink because it's not v. But here's the thing. You got to add or subtract what is not connected to v using multiplication. V is connected to x with multiplication. Minus 2v is not. So you add 2v to both sides. I got to move it to the other side. If it's not connected to the x with multiplication, get it over there. Now this is r plus 2v. Can't be simplified. All right, divide both sides by v. Divide the right by v, and then divide everybody on the left by v. So that gives us x equals r divided by v. That can't be simplified. But the 2v over v, v divided by v is 1. So you're just left with 2. Check out number 8. The red variable is now r. C equals 2 pi times r. Now this can be tricky sometimes because students oftentimes get into the routine of saying, I usually add or subtract first, then I divide. But in this case, there's nothing but a string of multiplication on the right-hand side. Everybody's multiplied by the red r, which means all you can do to move it to the other side is to divide by 2 pi. So R equals C divided by 2 pi. There's no simplifying that. All right, number 10. The red variable is h. So the area of a cylinder is equal to pi r squared h. This is the exact same situation that we just saw in number 8. Everybody's connected to h through multiplication. So the only way to disconnect them from h is through division. Okay, h equals a over pi r squared. And that's that. Which actually, I just recognized that I put A for this, but that's actually a volume formula. You don't have to change it. It's just kind of weird that I put an A where it really should be a V. Oh, I forgot. There's 16 problems on here, not 12. That's okay. We'll just keep working through it. All right, so number 12. The given formula S equals 1/2 AT squared. We're solving for A, so the red variable is now A. This one's slightly different. It's like, hey, everybody's connected to A through multiplication, but I'm not going to divide everything by 1/2 t squared just yet. Here's the reason why. Fractions throw the whole thing in flummox. What I'm going to do is put the A divided by 1, the t squared divided by 1, and the s divided by 1. I'm going to create one fraction on the left and one fraction on the right. So my fraction on the left is s divided by 1. The fraction on the right is 1 times a times t squared, which is 1at squared. You can just call it at squared, though. On the bottom, 2 times 1 is 2. All right, at this point, you guys should be able to cross multiply. 2s equals 1 times at squared. I'm just going to call it at squared. So now you can divide by the parts that are multiplied by a. A equals 2s over t squared. Looks pretty routine in terms of we've already figured this out. What happens when you take a whole equaling a fraction? Solving for the red W. Well, put the whole over 1. Now we can do cross multiplication. 1 times 4w is 4w. P times h squared is ph squared. Then you can divide both sides by 4. W equals, there's no simplification there, so you're just going to say it's ph squared over 4. All right, last one. Number 16. A equals F minus I divided by T. Solve the formula for F. So I see a fraction on the right and a whole on the left. Make this A over 1. So I'm taking 1 times F minus I, which is the exact same thing as F minus I. If you multiply by 1, nothing changes. On the right, A times T is AT. All right, now this is kind of tricky. Because usually, if you're going to your final move of getting F by itself, you would divide, right? This is F minus I, not F times negative I. Because it's subtraction, you have to add it to both sides, and that ends up being the last move in this solving of the equation. F equals, like AT and I do not combine. It's AT plus I. All right, guys. I hope this was I wouldn't say enlightening. I hope this helps you guys with the whole multivariable equation business, and that 2.14 now goes really well, and you max out that extra credit. So, thanks for watching.